Yeah, it's working. I will turn off my camera and then I will start sharing my screen. Let's see. Does everyone see my screen now?
Yes.
Yes.
Okay, and it's readable, I hope.
It's a
So-
bit tiny, but okay.
It's a bit tiny. Let's see if I can. Oh, that's too much. Is this better?
Yeah, I guess
Did
that's okay. Yeah.
Yes, okay for me.
Let me try the other Zoom functionality then. Is this better?
It's pretty much the
same?
same, I guess.
Yeah,
but it
I
looks
guess the
okay.
same. Let me go back to I'm thinking to use this one. So first, let me just inform everyone that, as you would see here, after talking to Jan and he's made some comments on the lack of progress the last few weeks, we decided to delay these later topics. So I will not be going into details about creating unit testing in C# or TypeScript, and nothing more about performance testing and generalization and these generalized topics. So hopefully we will have time to talk about this before Christmas, but I think we'll just wait and see to when we can find some time for this. So for today, then I'm going to talk about data models for fields. You will see that during my talk that I'm making use of the fact that we have already introduced data models for tables. And as I said in that talk, the three data model types, tables, fields, and logic, are closely linked actually. And as such, gain most of their, I would say, pretty unique functionality by having these links. So hopefully this will become more clear today when we talk about data models and how, about fields and how they relate to underlying data models. So I created another file. You will find this under Wiki seminar, so you can view it there. I can also show you immediately at the bottom here. I have created home assignments for you guys. So I want everyone to take some time before tomorrow's Scrum to solve these tasks in a separate development branch. So hopefully this won't be disrupting your current assignment too much, but after today's seminar, I would like everyone to immediately create a new develop branch for your own use. And in this develop branch, I would like you to create or solve the assignment that you will see down here. I will go into the details about the assignments after the talk, but just know already that I want everyone to spend the time between today and tomorrow's Scrum, and hopefully on tomorrow's Scrum, I will be able to look at, or just before tomorrow's Scrum, I should be able to look at your branches on GitHub to just verify that you have understood everything that has been going into these last few talks. But I'll come back to that, but just know that there's a kind of a participation requirement for you at the end there. So field models, this has something I've been working on as a concept and idea for a very long time. I think I already mentioned when I talked about data models that a common task we had, which was very demanding, was to extend and add a new field to an existing entity. A common problem would be add a field to project level or activity level, because often the user had already used all the different fields available, and he had some extra requirements that needed as a new field to be made available. And another thing which I realized after having worked with Adrega for some years is that we kind of repeated reference to the same field in many different places. And this has to do with how a rational database works with joins. It's not on this page yet, but down below you will see that this data model that I implemented is working together with the SQL query generator and to create SQL join expressions. And this is very important to understand that if you want to have a field model which gives you this flexibility of creating joins on the fly, not predefined ones, then it's kind of obvious that you want to have a recursive field model. So the entire concept of my field model is that it's not a single level or two-level model, but it's a recursive model. In a sense, it could be infinitely recursive, but I have put in place in the current implementation some cutoffs, making sure that the size of the field model doesn't grow exponentially. But what is actually a recursive field model, and how does that map out? So if you look to the project entity, it has a number of fields which relates to a user entity. So manager is a user, stage changed by is a user, locked by is a user, and last saved by is a user. So you can easily see that even the names are indicating that in this place will be a username, right? And this is working if you only look at the username, but if you wanted to make the user's email address, for instance, available, or the user's cost rate available, then you would have to add more fields. In fact, if you look to the user field entity, it's as such, it has different representations in Adrega, but a common one would have 17 individual fields for a user. Now, if you wanted to add support for all of these 17 user fields in place of a single manager entry, then you would have to add 68 fields, 17 times 8, right? So it would be manager email, manager's rate, etc., etc. And it's the same with last saved by email, last saved by code, last saved by a name. So having a recursive model helps quite a bit, because what you say is that these fields are associated with a user entity, and as such, immediately you have all the fields associated with the user entity available to be selected in the column editor, and also to be then displayed in the tables. So hopefully already now you see the benefit that we have like recursive field model. I also wanted to spend just a few minutes to talk about the old field model, its data structure in particular. So this might already be familiar with most of you guys, but we have in the database some tables. The basic one is 80 fields. So let me just show it here. And it has a key value called field UID. It has also a value called XBUID. It's not formally declared as a key value, but you will see that it's most likely unique for all field entries. So let me just copy this and open the table. And then let's just find all the user entity fields. So there's a convention in the use of the XBUID, in that often you would see the entity prefix with an underscore. So these are basically, you can see here, in this case, there's 36 fields being defined for the user. If you look to the AD user table itself, let's see. You will see that the AD users table itself only contains 16 columns, right? So you might be asking, why is there so many more columns here? And this is because this field list also contains joins. So for instance, a user has resource category associated with it. And that's basically a join between AD users and a category table. You can see here the old field model, which is non-recursive, still managed to reference joined data values, but they were actually enumerated as part of being under the user entity. That's no longer the case for the recursive field model. So another important table is AD fields client name. Basically, this is used whenever you change the field name in admin module. You can change the name to basically anything for most fields. And that user input is then stored in this table based on identifying the field ID and giving it a string value. If there's no user-defined or admin-defined, I would say, field name, then the field names are found in this table, and it's coded against the exp-UID value. So you saw this when I opened the fields, that the exp-UID was here. So this is kind of the key value against this language table. There's also another data field table, and this is kind of where the complexity of the old field model comes in play. It used to be that we had only these 3 field models data sets in the database, but then we added some requirements where we classified individual tables to be able to display different data. So there was no longer just one user entity as such. There were many different user entities, basically entities that are modeled after the use of the data table in that particular page. So it's important to look at this case. I can show this. So again, I want to identify what is a user field, and in the AD data field, a user field is not identified by the exp-UID prefix, but it's actually coded against this DAFI entity. So let's just quickly review this. What I'm doing now, I'm searching for the table and I'm pressing Control-Enter, and it opens the table for me, and I can enter this search term. So you can see here in this context, there is 37 user fields. I don't want to go into details now about the old data model since we're kind of going away from it, but just know that another important field is DAFI description. Basically, traditionally this has been used to give the name of the class property. So you can say this is the C# class property where you will find the value read from the database and stored in the runtime. There's also one additional table in association with this one, which again was put in place to allow the developer to tailor the availability of some entity fields. So combining these 2 tables allows the developer to actually specify what, if any, columns should be defined for a user in this table. And that's something I think Elena wants also to be able to reproduce in the new field model. but it's actually not in as part of the field model as such, but it's actually part of the view models, and I will come back to that more in later discussions. There's one more, and this is the newest one, table related to fields, and that is the dynamic fields. This is now currently only used for project dynamic fields, but when we created it, we actually created it such that it should be usable for any types of entities. So, but it has together with it plays together with the old tables in that it also has unique DeFi field and XBOD values generated when it's created. So whenever you create a project dynamic field, you will see an entry in this table, and this entry will have uniquely generated values for these key values. And actually, they will also have a listing in these other tables based on the key values that have been generated. Okay, so that's I think for now the old key field model. Let's take a look at how the new field model then is defined, and you might be surprised that it's not defined in the database as traditionally we do. For now, I've kept it to be in source code. There's two reasons for this. One is that there's no need actually to load data from the database. There's an exception though, because I created the field model based on in the database for its schema. So it's kind of not true in all sense, but most of the important aspects of the data model is already part of the code, and there's no time to read it from database. Also, the shape and properties of the field model is very closely linked to the source code. Much the same that way you see this being a part of the source code in Git repository. I do enjoy the fact that the field model has the same support. Having it stored in a separate database file makes it less apparent that there is often a one-to-one relationship between the source code and the field model. So having it stored in this way, closely linked to the source code, makes more sense in that, or rather than having it in database. Because if you should restore a database to a version which aren't matching the runtime, then often you will find yourself struggling because you have strange errors, because the field model in the database is no longer corresponding to the expectations of your source code. So just keep that in mind, that it's actually not a bad thing necessarily to have it integrated in the source code. But in the source code, where would you find the different key properties? So let me show you this. So first off, there's enum called entity, and let's go with this. It is not listed here actually, but it's mentioned further down. But this is kind of the starting point for the field model, and you can see I created so far a single entity listing here for all the data tables that I have managed to map from its SQL representation to the new dynamic contract. And the field model as such, it covers all the contracts I have mapped this way. So again, you will find user, you will find project, you will find assignment, etc. here already mapped. Then there's another central file, which is the field file. Let me open this as well. So when creating the field map, I need some attributes defined for that it shows it with the entity. So for instance, for the activity entity, I have a readable title that is displayed as a text string in the column editor. It also needs to know what database table it's associated with. You will see that you can associate it directly with a database table. It could also be associated with a view and marked as such. It can even be associated with output from a store procedure, and it's also then marked as such. So there's some flexibility in the field model itself, that the source doesn't necessarily need to be a table. It could be a view. It could also even be an output of a store procedure. There's also class called entity map, which is central. Let me open this. And this class represents everything that has to do with initializing the field model in runtime. So everything that needs to be initialized is either seen as data or business logic in this class. There's also statements to link entities together. I will talk more about this later on, but it's actually possible to make sure that one entity that you create can actually formally be linked to another entity to allow generation of SQL queries that will display the join operator. More on that later on. There's also, you saw, I talked about custom names being stored in the field client name and system names stored in this language table. As I said, my new data model doesn't make use of database structures for this. So instead, I have a source file here I can open. And basically, this defines the properties that are associated with the field. So you will see that if I go to the properties, you can see that it has a name. It has a default value sometimes. It could be a percentage field. So lots of properties, if you would like, for the field will be defined and stored in this entity runtime. And there's also, if I open this as a file, you will see that, for instance, the task ID, sorry, it has a name, it has an associated field ID, it has some rules governing how it's calculated as a summary. It even has a rule which is calculated as when inserting into the database, and it has a link directly to the interface. This one we saw the other day when we talked about data model, but these other aspects of the field I didn't formally introduce, but just know that there's a lot of, I would call it metadata for fields in association with in this entity runtime. So this is details about the enum. This is constructing the field map. This is properties of a field map. And this function I want to also mention is a function that creates part of the field map in a dynamic fashion. So part of the field map is manually added, statically added, but sometimes some parts are also dynamically added. So this will be typically dynamic field properties. So since when your user creates a dynamic project field, that is stored in a database, right? So, and it needs to go into the new field model. So that is actually the step in here. Extend the entity map from dynamic fields. There's also one function called extend entity map from database. And this is, I wanted to mention this because it's kind of an idea I had, which removes lots of coding. So there's no need actually to save table names and column names in source code, because I am actually asking the database for its own schema. So basically, this reads the basic properties of the database schema and makes it part of the field model in runtime. So as I said the field model was stored in source code, but not everything is actually, that's not completely true, because the field model will also adapt itself to the schema that the current database connection is showing you. So there's reading here table names, column names, but it's also a reading of the key column properties. So I think this would maybe something that Elena would appreciate. It's kind of advanced, I would say, SQL use. Anyway, the fact it remains that currently we haven't moved fully to the new data model or field model. So still for a few releases, we will have to be able to move between the different field models. And I actually have created support functionality for that. But before I actually show you how to convert the field model representation from one to another, we need to know a bit talk about field identifiers. And when I initially created this recursive field model, I struggled a bit to find a good way to formalize what should be the unique key for this field model. Traditionally, we use a integer value, but that isn't well suited for representing a recursive field model. And it came to my mind that everyone knows about files and folders, right? And this is actually a recursive model as well, you could say that. And everyone knows what a file path is, right? So if you go to a person and give him the path to a file, he would immediately know to browse it from C drive, users, John, documents, and find it, right? So this is obvious for most people who's been working on IT. And I modeled the same, the recursive field model the same way. So basically, it starts on the entity, then it goes through certain links, and then it ends up pointing to the property itself. So, and it's hopefully it's easily read. So here it's starting on the AD projects table. Sorry, this could be better. I would like to have seen it a bit better. And then it goes to locked by. And you can see here, it's located in this table as an integer. But then what you might be surprised to, it says username here. And what is this username? Because it's not part of the SQL declaration, right? But just know that the field model knows that this is a user entity reference. Basically, this number stored in this table is a uniquely defined row in the user table. So this username is actually not a column name for the project table, but it's a project name, sorry, it's a column name in the user table. So this actually reads quite easily now that you understand it, that you're looking actually at the username entry that's matched the project locked by value for the project. So this is a value stored and found in the database. This value, though, isn't stored in a database, and it's calculated. And we have kind of a convention regarding naming at the moment in the field model, in that database values are in capital, whereas calculated values, you would see that this is a Pascal case. So often, if the last name on the that you see here is a Pascal case value, then often, not necessarily 100% certain, but often it would be a calculated or aggregated field value. But as I said, the entire concept of identifying a field in the new recursive field model is that it's given a unique path variable. So these are two typical examples of such a unique strings. I should mention before I go down to the next section that even though the path variable is uniquely defining the field, in some cases you might think it's a bit long-winded, and it's true. It could be made more compact. Also, you will find that it's not possible actually to make use of these ASCII, non-ASCII characters in some places where you need to make the field identity known. I found it particularly a problem with trying to identify the field name for UI. So Telerik, for instance, doesn't allow unique column identifiers to have these non-ASCII characters. So to be able to circumvent that, I created an encoder which takes this long string and outputs a unique shortened version of it. And this shortened version, I didn't find a good name for it, so I'm referring it to as a row name. And I don't think row name has been used in SQL or anyone else, so I wanted to just have a unique, easily understood term for it. But just so that whenever you see row name mentioned in the source code, it means basically an encoded version, a shortened version of the path string. But I made sure that the encoding is also readable. If you know, look at the pattern, it actually makes sense. So let's look at the individual key identifiers for a field. So in the new version, you would see that the declaration would be project locked by username. In the old field model, there's two distinct values for it. One is a field ID value of 569. There's also a data field ID for 366. This dynamic key isn't related to this path, but it represents just the shape for what a dynamic field key is. So this is basically would be project dynamic text field, or it could be project dynamic number fields or whatever. But basically, when you create such a dynamic project level field, it will be given a unique GUID value like this. There's also, as I said, a concept of class property name. I talked about this, that the DAFI description, which is part of the data field table, has an entry which more than often would be the same string as the C# class implementation that is holding this data when read from the database. So I coined my own, as you say, I have the row name. You know what I mean by that. Just know that the static name in the new data model is the same as the DAFI description, in that it also gives the name of the C# property implementation. So it's possible to find this name in association with the path. I'll show you how these can be looked up together. And so for the static name, in this case, it would be project locked by. This is true both for the new model and also the old model. This is only defined for the new model, and you can see the shortened version of this long-winded path string. This value, even though it's unique, it's not guaranteed to be unique between different versions of Adrega. So it's very important that you don't save this data in the database. Only save the long winded one. This is guaranteed to be unique between different versions of Adrega. As such, you can migrate the database easily, but never save these shortened names in a database, please. Yes, I talked about where the name of the fields are stored when defined by the user in admin page or defined by the system. I have coined this term factory header. to identify strings stored in the AD language expression traditionally. And then I have coined the global header to be defined in the admin page. There's also a coined term local header. It's such so that the user actually are allowed to change column names in his reports or in his tables. So in this case, it's not stored in these system-wide tables. It's actually stored linked to the template ID or the user ID. And in the new data model, you would see that these facts are stored in data column details. Let me actually open it and show some code again. So you can see here properties for a path and then a given entity. It could be a customized name. It could be a customized width. Actually, name, the customized name is the title. And then it can be a customized alignment. It can be customized format, decimals, ratio, etc. So some of these fields, like title, alignment, format, decimals, ratio, are customizable using the column editor. Some of the other fields are just key aspects, and here to make it easy to understand and convert between different old and new representations. Hopefully you've been with me so far. Now that you know about the field models, old and new, I can't actually continue without actually talking a bit about the view model, even though there's no formal declaration of what the view model should be. I wanted to talk about how the view model currently exists, because it's important and has you can't actually make use of the field model without actually loading it as part of a view. So I wanted to also mention what a view model is. Traditionally, the view model is defined by a number of tables, AD Gantt view tables. So let me just show you the number of tables. You can see here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tables that contains data associated with a view. So one is dedicated to bar styles, one is dedicated to fields. This is actually a column selection for the view. Filters, groups, and sorts are stored in these tables together. And there's also some other tables which I don't actually recall now why they're used, but also attributes of a view. So when I worked on this in VPF, I created an alternative view model to simplify things, and everything is then linked to a single class. So you can see here, this class is a view, and it has the bar properties, columns, filters, groups, sorts. So everything that actually is stored in these tables are actually found as properties for this class. But this class doesn't have a dedicated table. So whenever you create an instance and save it to the database, it will end up in this place. So in our database, we have a dedicated table for storing JSON formatted data. And currently, the way we store these type of view data is as a JSON string. So if I open this table, you will see that it has a unique GUID. It has an identifier to help filter, and this is actually the view itself. So if I copy this quickly, enter it, and you can see here, see the structure of this view, which is the class structure that you see in UI config. So just know that when you are converting to the new view, you will be gaining an instance of this class. And when you want to save changes made to this view, you will be saving it to this data table. But regardless of where the view is stored and how it's created, the view will be identified by where am I now? Sorry, I'm skipping a bit ahead. There you go. View types. So if I go to this enum, this is also important because a view has a unique key, and it's the view type alongside the user ID. So let me open this, and you can see here we formally declare a view type basically for each and every table. So for instance, the admin user table has a entry in this global enum. Quick Approve page has its own. The project list page has its own, and portfolio has its tables. So basically, this enum together with the user UID is a unique lookup into accessing the view for this table. And the way you want to read these views now is through the new service I provided for you guys. So if I go to this implementation, you will see that this is a web service in the metadata service, and it's actually accessible as a service on the Angular side. So just know that you can request the number of views matching the view type and user UID, because I forgot to say that the key is not unique. It could be multiple views that are defined for this particular table. It's not just a single view. But once you have the list of views, you can actually ask for information about a specific view by calling on this one, and then you will be using the view identities implementation. And the view identifier for the new data model is the JSON identifier, sorry, the GUID, but whereas the old one has the view ID. So just to repeat myself, you saw in this table, the view have been given an ID, whereas in the old table, you will see that there's a unique view UID here. So that makes it a uniquely enumerated view. So yeah, I'm skipping a bit quickly now because this is a bit sidetracking from the field model itself, but just know that you can read the data sorted with a table by first accessing the view and then reading it, because the field that you the field is part of the view, the list of fields, the list of columns. Okay, the field model itself has an associated service, so I want to just highlight that. On the C# side, you will be using this service, and for instance, here, if you have a path identifier, then you can get access to the field objects, and from the field object you can get the title, the default name, default width, and all different aspects of properties what you have for a field. In fact, let me just quickly show you the structure of this. So this is maybe an exception to the rule. I usually don't add comments to my source code, but in this interface, what's so important, I felt that I wanted to explain a bit more about different important properties. So if you open this, which is a very central part of the field model structure, then you would see some more comments trying to explain what the values are and how they're used. So yeah. On types in a TypeScript world, the service is called iField service. I think I'm already stressed for time, so I won't be mentioning too much about Angular. Just know that everything that I talk about now holds both for the C# world and the TypeScript world. Everything is one-to-one here in as far as structure and functionality. But I have added lots of more usability functions to C#, so it might be more coding to do the same in TypeScript. But eventually, over time, I hope to reach the same level of functionality on TypeScript as I have in C#. But the field model and data model and business logic model eventually will be the same as far as functionality goes. So I wanted then to show you how you convert between the different field model IDs. As I said, we need to be working with both the old and new field models together. It's very important to be able to move one field to the other and vice versa. So let's see how we can convert one key identifier to another one. So let me look this up. So I created a unit test to illustrate this. So basically, I'm starting here on the new field model with a unique path to identify this, in this case, the user code column for the user table. The first step is to locate in this unit test the detailed information of this field, because I wanted to access the field ID. So, but having access to the field ID, and if that was my starting point, how would I be able to extract or find the path variable, right? So now the task is, given a field ID value, how to find the path variable. And you can see here how it's done that. I'm calling on the fields service. I know that the field will be associated with that user entity, and then I pass it the field ID, and I will receive back the unique path. It's very important to understand that due to limitations between a recursive field model and a non-recursive field model, it's not possible to map a field ID uniquely to a path. So in addition to the field ID value, you always need, when converting this way, entity also. But I have yet to find a single place where I don't know the entity when I need to convert it to the path. So that's basically given in the context, the coding context. So there's also ability to convert the internally defined row name to a path. So basically, if you have the row name available, the row name is, by the way, is used in the concurrent dictionaries in the data model. So the path is not a good key for a dictionary, whereas the row name is. So when we save values or store values in a concurrent dictionary, it will be stored with this key value. So that's why this is kind of important process as well. So given such a dictionary, how would I know what path this dictionary is storing values for? Well, you can take the dictionary key value. Given that you know the entity, you will get back the path variable. So this is a very convenient way to convert between different view models. And of course, as you see, if you have the path, you can just ask on the field object, and from that you will get the field ID. Actually, there's more than one. That's why it's impossible to actually convert from a single one to another one. But there's also, there's multiple field values, but there's only one row value. So that's also an important fact to note there. Now, next step is actually to try to explain the relationship between the field model and data contracts, or sorry, dynamic contracts. And one key factor to know is that before you initialize construct dynamic contract class, you should always make sure that you have initialized the associated field model. Now, I have set up the runtime so that you don't actually need to do this, But if you create your own web service, then you want to make sure that you call on this function as part of in the first line of the web service. If you create your own unit test, you want to have a call on this function as the first line in your unit test. The runtime is initialized in the desktop client already for you, so you don't actually need to do too much there. And also the same is for the web client. As you open the web client the first time, all the different field models will be instantiated. There's one key aspect. Let me open this because it's kind of important to that you guys understand. If I go to the implementation here, or use case, I would say, of this, and they find something that is not testing. So sorry, this was the testing version. This I wanted to mention this one in detail, and this has to do with serialization. So sometimes you, for instance, in this case here, you are passing to the web service data that is associated with a data contract, and then you can't actually decode or deserialize the data contract itself as part of the runtime framework. You can't. So basically, you need to make sure that you pass the data from Angular to the server as a string because it can't be decoded yet. Then you initialize the entity map, and only then can you decode or deserialize the data that contains this data dynamic data contract. Because as I said, you can't construct a dynamic data contract without actually having a corresponding entity field map constructed. That's how closely linked these are. I think I skipped this one because I already covered that. So one thing I wanted to highlight is also, now that we have a field model and individual data contracts, I have a way to enter in the field model a physical, if we could call it that, link between the contracts. So I wanted to illustrate this, and it's a good thing, I think, to illustrate it by creating a unit test. So the unit test will be, that I show later on, will be using the fact that I have in this entity map, as I said, this is a central class for initializing, creating the field model. I have in this entity map a function which links the user entity with this table, this AD home user settings table. This is itself already implemented as an entity, and as such I can utilize that. So let's look at this unit test. So you can see here that the unit test starts with initializing the field map, as always, and then I create an instance of the user dynamic contract. Then you might be puzzled by this. What's happening here? Actually, what you're doing, you take the dictionary that is created, and you pass it as an input to constructing the user settings dynamic contracts. And this allows you, this combination allows you actually to store data in the same dictionary, even though they are actually related to different SQL database tables. So in this dictionary, then after these two lines, you'll see it storing the name and code, but also it will storing the fact that last plan page enabled is true. Now I'm running a SQL query to get data from the user table and the user dynamic settings table. And let me just show you how that looks, how it's generated. So I go now to file system and search for the name. Then you will see that I have this verified one. Then this is output of the unit test, and you can see that the output is the SQL query that it generated in combining these two data dynamic data contracts. And you can see here, as I said, it's actually asking for data in the usage table, but it's also asking data from the home settings table. And it's actually doing that using a join between these two key values. So if I go back to the entity map, you would see that the key values are identified between the two tables. So these are the equality here. It's kind of seen here, user ID matching user UID. And it's actually linking the user table formally to the user settings entity. So let me see what I tried to do here. Let me actually run this as a unit test. I'm going to show you this output. Let me make this a bit bigger. So here is the SQL query that was generated, and here I actually have I'm running this query against the database, and I'm outputting some data. So just see here in the source in the implementation that the first entry here is actually, let me find it. It should be maybe get the data. Here we loop the row counts and we add it to the output. Yes, sorry. I'm struggling to find where actually I write out this line. Just bear me with a minute. Let me try to find it. Yes, okay, here we go. So you can see here I have many rows from returned from the database. Basically, I have a dictionary entry for each row from the database. And what I are able to do here is formally declare a new instance of the user dynamic contract with the dictionary read from the database as input. And I do the same here. You can see here, this dictionary entry is from the database reply. I formally created as a dynamic user settings dynamic contract. But in this case, its origin is part of a user entity. So I have to pass in the user entity as well. In this case, you will see that I'm able now to reference the user ID, the user code, the username. Basically, these are the Pascal properties named, or the class names using Pascal casing. And you can see here, this is also the same, but this is not actually formally declared in the user contract. It's formally declared as the setting contract. But yes, this is a single row, is a single reply from this database query. And through these constructors, I'm able actually to access the data through these C# properties. So that's what I wanted to highlight. There's also a way to access these values using the more generalized access method. So here I formally declare these values to be part of a contract, but you would see that in this case, the row itself is an entity dynamic row. So you recall, I have the data model in 3 layers. One is dictionary, one is the in between layer called entity dynamic row, and then we have the contract layer. So this unit test is a bit advanced because it shows you how you can output the third level, but it also shows you how that you don't actually need to convert it to the third data level to actually have meaningful output. So basically, this is the output you see down here, formatted in a really nice way. But also you would see that I put intentionally some key names for the columns. So here the name is username. This is the static name, and this is the row name, and this is the field ID. So all of these are key properties of these columns. And I think I will leave you to study this example and try to understand the input and output on this. But just know then that even though we can declare individual dynamic contracts, there's a way in the data model, a field model, sorry, to link them so that they actually can be used in join operators in a database. I'm going to wrap up quickly now. Just know that if you study the code, you might be surprised that there is actually 2 almost fully workable APIs. When I first implemented this field model, it was using some old convention for naming, but at the same time, I wasn't too concerned about the complexity of the API. I wanted to have an API that was working, and I continuously added functionality during the implementation. And I realized eventually that I should be able to, and I should actually hide much of the complexity needed by the implementation for the end user. So basically, I'm thinking of you guys as end users more than actually developers of the field model, for now at least. And as end users, I hope they will find that the API version number 2, it's much simplified and easier to use. So basically, the API enable objects here contains much fewer attributes than you would see in the fully implemented ones. But these attributes basically are only needed to generate the field model, and as such hides and obscures the more important facts for the use of the field model. So now I'm running out of time, I think. I want to go through your assignments. So let me quickly remove everything else. What I wanted to you guys is to formally create your own dynamic contract based on certain database tables. So far, these database tables, I don't think I have made. Maybe this, I need to double check this, because Anatoly, you might actually have already been, your case might have already been sold. Check. Yes, so Anatoly, just know that manager is already added as entity, so don't be confused by this. But I don't think I have created a manager dynamic contract. No, so there's no manager contract, so that will be your starting point then. Well, just know, Anatoly, that I already created an entity for it. I might even have created this dictionary entry, but I haven't created the step 2 to 5 here. So that's, I expect you to do, Anatoly. The exceptions table, Andreas, is that currently in use? I found it by accident, and it might be a good for us to use it. What do you think?
I think it's, I'm not sure of the status, but I thought it was used.
Okay, yeah. Certainly then we should have access to it. So basically this is a table which has a unique identifier, and it has a number of properties that includes, I guess, yeah, everything that involves an exception, I guess. So Alexei, I wanted for you to map this table to a dynamic contract and go through these steps. Hopefully this is something you can do before Scrum tomorrow. Anatoly, I want you to do the same for the manager table. And Olga, I gave for you this AD projects last used table. Is that understood?
Yes, okay.
Yeah.
One thing I want to stress also
I'm not
is,
sure about tomorrow.
but I want you to start on this now, Anatoly. And if you can't make it to Scrum tomorrow, then that's okay. I know that you're still installing your developer tools and things like that. But let's see where you are on tomorrow's Scrum. And of course, if you need more time, you need more time. But everyone else, I hope that since you don't actually are, you're not configuring your systems at the moment, as Anatoly is doing, hopefully you will have time to fully implement the steps that are outlined down here. And this also is like a test for myself to know how complex this stuff is for you guys, both to implement but also to understand. So maybe when you try to do the steps, you fail because there's some knowledge you don't have. And hopefully you will find that by reviewing the videos that I put up. But no, if not, if you think you can save some time, then also please contact me and I will try to answer it on for you. There's one thing though I wanted to highlight, and that is something has been saving me a lot of time recently when doing this kind of refactoring and also code cleanings, and that is the more advanced text editing functionality which I outlined the other day. So just to repeat myself, so say I wanted to carry these into an interface. What I'm doing now is to highlight these as a selection and then Control-C to copy. And then I'm quickly going to create a mockup. And then I Control-V to insert. Then I select everything and I press Shift-Tab to have these indented this way. Then what I do now, this is the magic actually. I'm holding down my left Alt button on my keyboard and dragging down the mouse. You can now see that I have a movable cursor. I go to the start of the line, I press on Tab, I write int, then I select by Control W the entire word. Then I run Pascal case as an action. Then I hit on the end key and I do get, sorry, it's should get escape set. Now this is not a class, so it will be complaining. So now I created, so sorry, this should be set there. So you can see now that I created actually a class with, or it could be an interface, sorry, that one. So you can see now how quickly I was able to create an interface with these names that I brought up from the database, right? So hopefully when you do this, these tasks that I outlined for you, you will make use of similar advanced editing functionality, because really it's a big time save when you have to repeat yourself otherwise. I put down here some hints to where you can find and access these more advanced functionality elements. As far as converting between cases, I found it was actually, I was using a string manipulator plugin for that in Reader. And I also found by searching in the net, a similar functionality available for Visual Studio. Are there any questions regarding your assignments? No, I'm 1 hour, 10 minutes into the lecture. So let me recap what we've gone through.
Sorry,
So,
Parag,
yes.
I have questions about your presentation. If I right understand, all JSON string we will keep in one table. I think that at first we should add additional fields date modified for understanding in what time row was inserted into table. And maybe we should create some JSON tables for keeping different rows, maybe for different objects. Because if we will keep all data in one table, in the future, this table will be huge.
And about indexing and so, wouldn't it be very inefficient?
No, if will be million rows in this
Yeah,
table.
I think that's. I had the same question. We should split that up, even if the tables are identical in structure. We should split it up, dependent on what the table is supposed to be used for, instead of just adding everything into one gigantic bucket.
I don't mind that actually, to have dedicated tables for records that are following the same pattern. I don't mind doing that.
Mm.
As far as last saved, Elena, dynamic contracts will be derived from this base class. And part of this base class is actually implementation of last saved functionality. And it's also last saved by who saved it last saved. So there's some benefits in that. Last saved, for instance, is a column that you can access this way for new entities. Old entities wouldn't support this because for instance, this exception table that I wanted the guys to convert would not be supporting the last saved. But if you added this as a column to the table, it would actually be reading and saving data into it.
No, I think that it should be saved because it's if I okay, it means that if I will add new columns in this table, then you should add this field in the code in constructor, maybe any class, and it should be saved. But this data should not be visible for user in any view. And it is second question.
Yeah. Sorry, I think I lost you again. I am talking about dynamic data contracts. You're talking about the view again now, aren't you?
Yes. Mm-hmm.
Yes. Okay.
About this table. And second questions. I don't agree with you that all columns from table should be visible in view. We should review it separately. But it seems you have algorithm for hide or show columns in the view.
So basically today, Elena, just know that what I've done is try to be able to have a show all or not show all. If it's show all is disabled, basically you will only be showing fields that have been given already in the old model, a field UID or a data field UID. So basically what I'm trying to achieve is that, for instance, if you open the admin users page, that has been given view ID, right? And the view ID lets the current column editor know what fields to add to the column editor, right? I have when creating the field model for this particular case, I tailor the field model so the only in the field model you will find fields matching the view configuration that is already present. So there is already in the solution a way to turn this on by default. It's on actually, I think. So, but yes, what I have in mind actually, this is kind of maybe a bit beside what we're talking about today, but let me just log in quickly and show you. What I have in mind is that you should be able to run the application in a certain elevated property maybe logged in as sysadmin, what you will find that when you open the column editor, it will be down here some buttons to save the current column editing layout as a filter, right? So basically here you can have access to all the fields on left side, and on the right side will be the selected fields, which goes into the selectable fields for the user, right?
Yes.
So this is the way I think for you and Andreas to customize each individual table such a way that you only show in the column editor what you feel is meaningful for this use case. And that
Okay.
information will be then stored in the database and used by the field model when you open the column editor here.
Yes. Okay. Can I call you after demo and need to discuss one case which I showed in develop branch, and I would like clarify how manage what wrong in
Sure.
DB. Okay. Okay. Good.
Anyone has any comments? Yes, Andreas.
Yeah, I have some more questions. I guess Elena touched most of what I had, but let me see. You have columns like you had in your description there, where you select project locked by, username. But in the existing model, we have, I think, a column called project locked by, and then it displays the username. Do you want, we probably discussed this before, but do you want to completely replace it so that we don't have this easy one column selection where you can select project locked by and then you get everything? Do you have to go this path? Project locked by username?
Sorry, I lost track. If I open maybe the desktop application, because that has a more extensive field column selector as it currently implemented. Let me open it. Again, now we're talking about the application of the field model or how it's used, not the field model itself. We're kind of talking about the view model, and as such, maybe it's a bit out of scope, but it's still, let's spend a few minutes discussing this, because obviously one doesn't exist without connection to the other. Let me try to resize this window quickly. And then so open, let's do the most advanced one, which is the approve column editor. The approve column editor have access to activity data, project data. Now, so this is the most advanced case currently, Andreas. Do you have any observations to give us on this?
I think if you go to the project list, you have a column called project last saved. No, projects last saved by.
So let me collapse everything. Then currently I'm showing all light, and then you have last saved by, right? Yes.
Last saved. Okay, so you have to do.
So here you find last saved by email, last saved by login, right? Yeah.
Okay. Okay. Then I have another question. It's a hypothetical, I guess, because we don't have this functionality implemented yet. But let's say you wanted to display in an activity table. You have activity, and then you want the parent activity's name displayed as a column.
Yeah.
Would you be able to do you want to be able to change the value directly there?
No.
Should I be no? Okay. So it should only be read only if you sort of iterate through different layers.
Correct. I want to
Okay.
restrict saving much more than loading data.
Okay, that makes it a lot less complicated. Okay, thanks.
Any other questions?
I think that in the future we shall discuss the list of visible fields in any case, because here activity level, I'm not sure that it is really need fields, and need to check what we display for these fields. Because check 200 fields, it is unreal.
But maybe since I have this open on my screen, I want to just say that this is a good visualization of the recursive field model, because it actually, as you see here, I can expand on activity, then I can expand on original, for instance, and then I will find original start and finish in this case. I can further go down and find numbers. So, and this is actually values already on the activity level, but it's actually they're presented in a hierarchical way. But this is actually a recursive step. Baseline is not stored and on the activity level, but it appears to be a part of the activity object, right? So even though I can expand it now and find baseline start and finish, in much the same way I can find these numbers, which are on activity level. These are actually on a different table, but the user doesn't need to know that. And the way to select a field is the same regardless of it's a join operator in the behind or it's just a select visa select. So yeah, the recursive field model makes this very natural to code and work with, both to coding but also as a user interface, I think.
Yeah, but here you have the same problem as we on old implementation. You have on one level actual fields, for example, and number fields. It means that you divide by entity and by type on one level.
Yes, this is since Andreas
Yeah,
he said that now we must use the old type grouping as well. We can't just do entity grouping, and I kind of agree with Andreas in that if you don't only group by entity but also by type, it makes for a flatter list. And the users, the current users, are kind of familiar with this grouping situation.
no need think. Maybe create a general section, for example, as Primavera. He located all general fields in one section, and the names are general, and maybe and inside general divide by type.
Okay, I haven't played with the Primavera application, so maybe we can learn something from it.
Okay, good. No, in any case, it is a discussion on the
yes. But you can see why I'm hesitant in actually. I haven't even said that I wanted to talk about the field model as part of my seminars.
Yes.
So the view model. The view model is not here on the list because I think it's too premature to decide on what is the ideal view model for us, and I certainly it's out of scope of the current release to actually dictate what should be the generalized view model in our solution. I think we should and continue to discuss it, but for now I think maybe we should just avoid that topic altogether as far as the current release, and yeah, go with a simple solution, practical solution, which is kind of familiar to everyone that has already been using Andrega. Any other comments? No, in that case, I will stop my presentation and wish everyone a good day. And let's talk again on tomorrow's Scrum. Hopefully, a few of you have then been able to solve your individual assignments. You will find everything as part of develop branch already. Let me actually double check. I usually should do and see if I have an outstanding commits. That should be part. Yeah, there's a minor cleanup. Let me add it in a way. Added some spaces. Commit and push. So yeah, everything you find should be there. And when I terminate the meeting now, you should also have the video available on Teams shortly. So yeah, bye for now, and let's talk again tomorrow then.
Okay, thank you, Brant. Bye bye.
Bye bye.
Bye bye.